Good morning, good afternoon, and good evening, wherever you may be in the world. Welcome to my channel. Thank you for tuning in. We will be talking about optimization in this segment, and it has to do with our exam preparation series. We will be interacting with question 10 of our examination paper, which is the second last question. After this, it will be question 11, which will be talking about probability. Okay, so those are the two contexts that we'll be engaging with in this last two lessons that has to do with paper one, mathematics exam preparation. All right, so let us take a look at question 10. Here you go. Okay, so we are given the context such that there are two quantities involved, and that is volume and surface area, as you can see. We are asked to find the value of the radius such that the total surface area of the tank will be at a minimum. Okay, are we given the volume? Yes, it is 1,000 cubic meters. So we're going to substitute it there and leave that as it is for now. Okay. So now we see that there are two equations to work with, and one equation, which is this one, will be used to eliminate one variable in the other one, which is the total surface area equation. So which variable will we need to eliminate? The height, because we are looking for the value of the radius such that this quantity will be at a minimum. Okay, I'm going to work with that and obviously make h the subject there. It's 1,000 minus 4 over 3 pi r cube. Okay, and we're going to divide by the coefficient here of h, giving you that, where we're going to take that into that guy right there. Okay, and develop an expression for the total surface area that we can differentiate, equate it to 0, and find the value of the radius. Okay, so that's where we are. So now we are going to have this TSA is now equal to 4 pi r squared plus 2 pi r. H now is that 1,000 minus 4 over 3 pi r cube all over pi r squared. Okay, that is the h from there as well coming into there. Okay, obviously we'll need to clean up and ensure that we are working correctly. Total surface area is 4 pi r squared plus, we distribute into the first term here. What will we have? 2,000 pi r, okay, minus, we distribute into the second term there. That will be 8 pi r over 3, but pi times pi gives you pi squared, and r times r cubed gives you r to the power of 4. That is over pi r squared, and that is also over pi r squared from there. Okay, so let us work carefully to ensure that we account for all the terms. 4 pi r squared plus, what's going to happen there? Cancellation will happen, and that r, the one r there, so you're going to have 2,000 over r minus what? Okay, so the pi and one of the pi's there, square and 2 r's there, so we'll have 8 pi over, or 8 pi r square over 3 that remains in that particular term right there. Okay, so we have total surface area. I'm just gonna use S with respect to r here. So it's a function of the total surface area with respect to r, and r as being the only variable in the expression there is definitely equal to that. 4 pi r squared plus 2000 over r minus 8 pi r squared over 3. Okay. So now we're going to get into differentiation, because now we've developed what? The function from the context and the equations that were given, and we are at this step now. Let us look at the next part, which is differentiation and finding the value of r. All right, so we have this equation now, and we recognize that these two are like terms, and we can simplify to have s with respect to r. When you do that, you're going to have a 12 minus 8 giving you 4 r squared over 3 plus 2000 r to the power negative 1. So we've prepared the function. It is an exponential form or power form, and therefore we can start differentiating. It is indeed ready for differentiation. So at minimum total surface area, or for minimum total surface area, what do we know? This implies that this equation, or s prime with respect to r, is equal to 0. Okay, so then we bring it down here and find s prime of r being what? 8 pi r over 3 minus 2000 r power negative 2 is equal to 0. Okay, now transpose there. 8 pi r over 3 is equal to 2000 over r squared. Okay, cross multiply to get what? 8 pi r cubed is equal to 6000. Okay, division both sides by 8 pi. R cubed is equal to 6000 over 8 pi. Okay, and therefore what is the value of r that we're looking for? It will be the cube root of this fraction right here. Plug that into your calculator, you'll get about 6.2 meters for a minimum surface area. So this takes care of this optimization context or question as well, and it was really about applying our minds, picking the right formula, as well as manipulating correctly and working carefully, obviously, to arrive at the answer. Okay, this is a standard question, you'll always get it, so therefore let's ensure that we master this part of applying calculus principles in real life, situations such as this one. Good stuff. So now we are heading off to the last question of the paper that has to do with probability. Okay, so let me meet you on the other side in the next segment. All right, thank you for tuning in. See you there. Sharp.